Good morning, everyone.
Morning.
How's it going, Jamie?
Doing well. How are you?
Good, good. Thank you.
Excellent. Excellent.
Hey, Henry, Allison. I see me, I see Michael, Murali, Nikhil, Shannon, Wenjen, Yuki, Yoran. Letting others join in as we speak. So let's get started. So welcome back, session 9. We will learn how to do forecasting using Excel and how forecasting for business is done using time series analysis, which you may have covered. Now, in any of the courses that you guys have taken, and I know you're about to graduate, so you've taken most of them, have you covered time series analysis in this curriculum? Forecasting, time series analysis concepts.
Is that the same as using moving averages?
Yeah, moving averages is one of the techniques, yes.
We did a little bit of that in supply chain management.
Awesome, great. And how about using time series analysis and forecasting at work? Anyone? So Yuki, you're saying your first year MBA, MSBA, we haven't done that. Shannon, you're saying you took a sales class in marketing. So Shannon, was that course completely on sales forecasting, or was it like a session in a marketing course?
Completely on sales forecasting. We learned a bunch of models, and it had a lot of the time we were looking to do like how much advertising would affect overall sales. So like BAS model was one of them. But it was more modeling it out versus time series.
Okay, typically we use a time series, which is historical data to forecast future. So did you guys use historical data, or did you guys use different types of models? Not historical data.
I'm trying to think. I think we did both because we learned a couple different types of models. But some, I know like with BAS, you have to, you're taking historical data. So I guess it would have been both. And then you were trying to identify trends with if you promoted through a retailer, what the likelihood would be to pass on, or I guess we're kind of looking at profitability based on current data to try to predict.
Okay. Yeah, BAS's model is really interesting because it looks at new product releases, which has very little history or no history. So when iPad was being first introduced to the market, there was no such thing. So how would you look at, forecasting that is, something that all industries are challenged with. And what they do is they look at similar disrupting technologies in the past. So they may have looked at CDs when they were released first, or DVDs when they came to the market first, or radio when it first came to the market, or other technologies that first came to the market and disrupted the market in a big way. How did that curve initially with a slow period, and then gradually, picking up, and then all of a sudden it jumps really high and then gradually stabilizes. Those curves, innumerable curves, are prepared by BAS's model, and then it kind of fits the new release product launch into that spectrum and tries to think what would be the best way to model this, given that there is what is called a hazard function, which is also another way of saying that people have a way of, osmosis or diffusion of ideas, where people are talking to other people, and then all of a sudden it catches on. And with today's social media, that's taken a huge impact because you get a lot of data from Twitter and Facebook and LinkedIn, and then see how technology disrupts. So Bess's model is very interesting, although we will not cover that in this particular session or class. It is something that many of you who are interested in marketing models and marketing, sales forecasting, it's a very good reference that Shannon just brought up. So look it up, and there are lots of references on those. What we cover here, though, is the very basics of using Excel. Excel does not let you do a huge amount of forecasting, although the advanced solver platform may have some variations, but mostly we use some fundamental theories of forecasting based on historical data. When we have the sales of one particular item registered for a period of several months or maybe years, then can we project into the future how much that sales is going to be like, given that there are seasonality variations, there is a state of the economy, and those kinds of things. So it comes in handy, and Excel has very cool ways of doing it. Anybody else using forecasting? I see another comment from Truscout. Who is that? True Scout? You work for the government, so no experience with this. Okay, Pedro. Not yet. Okay. Anybody else? Great. So that gives a good idea on where we should really start looking at it. Maybe reviewing and refreshing the ideas are useful. And some of you have, after talking to some students after midterm, I realized that some of you have are either from the MBA program or have not had the opportunity or exposure to look at some of these concepts, while on the other hand, the global supply chain students have had the opportunity to work on these areas and have had some exposure. So for those students, this might sound a little bit of a refresher, if you will. And for those who have had no exposure, this might sound as if we are going a little too fast. So I'm trying to find the right pace for sharing this with you and showing you how to do it. So we will have long pauses when we will actually download the spreadsheet and start working on it together, and then come back and share our screen the usual way that allows you to think through what you just learned and then apply it directly so that you could, retain that information to be able to practice yourself and learn this a bit more. So basically last week, okay, before I start reading that, I see a very good comment from Henry. Refresher is good, Professor. It's difficult to recall these skills if you don't apply them at work. Absolutely, and that's why we want to talk about the basic concepts and make sure that we practice them a little bit. And then I really, really, really encourage you, when you go back to work, take a time series, apply this and see what you get. Compare it with whoever the expert in that area is, what they got as results. Maybe you will find out that they use much more sophisticated algorithms, but at least conceptually you'll be able to understand what they're doing and how they're doing it and what the logic is and how to measure the error of it, what's forecasting accuracy. And as you know from global supply chain, that's the one big thing that influences inventory, right? Sales forecasting is directly going to influence your inventory. Of course, lead times are also going to be, influencing your inventory, and inventory is all what global supply chain management as a profession really does to manage their performance. So, great point, Henry. So, last week when you did regression, remember I warned you that do not try to predict a number outside the observed domain of the independent variable x, right? And we said if you try to get a y for an x which is outside the range, you don't know what the curve is going to look like or whether it's going to change its course. So be careful on that, right? But if you have a variable's own history, right, on how it has performed over a period of time, you could start gradually forecasting into the future. Now, based on 1 year of data, can you forecast the next year? 1 year of data in monthly buckets? Well, not quite still. You should be able to forecast the 13th month, maybe the 14th month, maybe the 15th month, but not beyond that. Again, you need to be very careful beyond going 2 or 3 observations, because that's when the unknown comes in and the forecasting variance becomes bigger. The uncertainty factor becomes bigger. The good thing about using history is that it avoids the need to specify a causal relationship like regression does, and to predict the value of explanatory variables. You don't have to do any of that. Just one variable is good. So one column and you're done. One column of sales or one column of performance of any variable for over a period of time. So that's why it's called time series method of forecasting. So it's a set of observations on a quantitative variable collected over time. So, for example, Dow Jones, and you have been following that. It's been going up and down in the last few weeks. 3 weeks before this process started happening, nobody in the industry could have forecasted what it would do in terms of drastic drops and drastic going back ups and then drastic drops again, because there's a whole lot of political, social, economic, cultural, lots of different unknown variables that affect stock prices. And so therefore, just taking a historical look at Dow Jones, it is almost impossible to still forecast what's going to happen in the next few weeks out. So it's one of those examples where time series forecasting so far has not been able to, prove its predictability, although stock market shareholders and analysts and financial analysts will tell you that they have a magic algorithm so that you could invest money there and they will predict that it's going to go up. Long term, yes, it's been going up, but what's going to happen next week or next month, it's very hard to predict. However, there are variables like sales, inventory, customer counts, interest rates, costs, etc., that have a bit more predictability. So the first thing to ask yourselves, using common sense, using business knowledge, using expert commentary, using research, is this variable something that is predictable, to the point that have people been able to successfully show that they had very little error in forecasting when they have forecasted something for a few periods out using this particular variable, right? So often independent variables are not available to build a regression because you don't know what variables are going to be affecting that. So what you do is you look at past behavior of that particular variable in order to predict its future behavior. So some important terms are stationary data, which is a time series variable exhibiting no significant upward or downward trend over time. It could have a mild trend upward or downward, but significant upward or downward trend over time, it's growing up and up and up, significant. That's not going to be stationary. That clearly shows that it's becoming gradually an upward trend or a downward trend. For example, stock market, again, it's non-stationary because over a period of time since the 1910s, if you start looking at the data, it has had an upward trend over the last 100 years, right? Non-stationary data does basically exhibit that, and that's why stock market data over a long period of time is non-stationary data. And then also there are stages in which you have a certain variable taking a certain level, and then it leaps up to another step and then maintains that for a period of time and then leaps down again for a period of time. Those are examples of non-stationary data as well. But then, as you all know, particularly if you have been in retail or in CPG, consumer packaged goods, or FMCG, fast-moving consumer goods industries, there is a lot of seasonality. Sweaters, for example, will have a lot of seasonality. You're not going to really sell a whole bunch of sweaters in July, at least in the northern hemisphere. And you will sell a lot more during Christmas in the Western world. And so therefore, looking at seasonality is an important part of understanding time series. Amazon, for example, between October and December 24th, has the maximum sales in this entire in an entire year, and that's why it's called a peak period. And so during peak, the amount of work, the number of people engaged in the work, the amount of inventory, all of that significantly goes up. And then again, you can predict that next year during peak, at least in North America, it will have that leap again. And if you understand how to operate, how to forecast, then what it does is it allows you to predict the number of people you may need to additionally hire, the amount of inventory you may need to stock, and in what location, what's selling more, so that you have the global supply chain objectives met, which is fulfill customer demand. And then the second part is at that minimum total supply chain cost. So forecasting has a critical input toward becoming successful in business, particularly when it comes to global supply chain management. And of course, marketing initiatives and sales. Marketing executives will spend a lot of time in understanding what promos do to their ads, or what promos do to their sales, and how to prepare for it. But then if they're not talking to the supply chain team, chances are that they will create a demand that will not be fulfilled because there was no inventory that was predicted to be there anyway. So there are reasons why we take the trouble of actually engaging statisticians and doing some solid time series forecasting. Some models, and there is a reason that they're called decomposition. So time series model basically says that multiplicative and additive are two examples of models where a number that you need to predict in the future is has four elements to it. One is if it has a trend component, which is long-term trend, is it going up or down? Then it may have a cyclical component, which is more about every 4 or 5 years, the economy may have a boom or a recession. And in that case, the entire sales pattern will look very different from one period to the other. And then there is seasonality that I just told you about, how seasonality affects the sales. So, and then there is something that you cannot really predict, which is the error or random component. And if you look at the multiplicative model, it's telling you that what I'm going to sell may be based on the product of these four factors. So let's say the base case was 100, which is T, which is where it is right now. But this is actually a boom cycle, so it's probably going to be a 10% rise because of that. So it's 100 times point, basically 1 plus 0.1, which is 110 now, multiplied by a seasonality factor. Well, if it's peak, then it's going to have a 40% hike. So it's 110 times another 40% of that, so multiply by that. And then the error component, or it's actually a random component to be more precise, that I don't really know about how much it's going to fluctuate because of unknown situations. You put a number there and you estimate that as well. So all of a sudden that number becomes 150 plus a little bit of an error, because now you're in a high season and you're in high cyclicality. But now you go to summer, that falls down and it becomes 89 maybe, or 94. So that's one way of looking at it. Additive says that the factors are to be determined in such a way that you add those numbers up and you will come to a number like 150 versus an 89, depending on which season and which cycle you're in the economy. So that's how you look at it. And for either model, the factors are calculated in such a way that you eventually end up with the same forecast, but there are different pluses and minuses of each of these models. So this is what time series looks like with a trend. Base case, in the left hand side, 100, trend makes it up to 110. cyclicality, brings it up to 140 maybe. So you look at the graphs and patterns of the data to determine, eyeballing the data and then taking a look at the picture, what it looks like, what kind of behavior it has. So classic decomposition, what does it do? It takes away first seasonality and cyclical components from the data and finds the true base, whether it has a trend. And then it adds them back as it forecasts in the future. When you're forecasting without decomposing the data with seasonality and cyclicality, it's very difficult for you to forecast in the future with all those variables combined, because you don't know how it's going to affect at that time, because that's a different period, different season, different cycle it's in. So first, find out how much component power those things have. Does seasonality have a lot of power? Well, take it out from it. Does cyclicality have a lot of influence on it? Take it out from it. Find the basic trend, forecast into the future 1 or 2 periods, and then add back those factors of seasonality and cyclicality to kind of up or down it, adjusting it a little bit to have a much more accurate forecast. But unless you knew what those factors are, you would not be able to forecast so accurately in the picture. That's why we call it decomposition model. How do we decompose from data what effects it is already carrying as information for you to go decipher the data with and then go and predict. So this is a picture of how it looks like. If you look at the original data, which is Y, which looks like this curve over here over a period of time, you could visually see that it's going down and up and down and up and down. So there is some seasonality to it. And then you're also noticing that it has sort of an upward trend. It's going up with time. Okay, so you know that there is trend. You know that there is seasonality. You know that there may be some cyclicality, although just in in 18 quarters it may not be so obvious. But if you look at 54 quarters out, like 10 years out, you may be able to see that it's operating in a similar pattern, but in a scale which is a lot less because it was recession time, or maybe a lot higher because it's actually a boom time. And that's how you will be able to de-seasonalize it and then de-cyclicalize it. And then what you're getting is, once you de-seasonalize the data, you get this little pink line. If you're not line, but curve. If you notice that it's a lot less jumpy than the original data because you have taken the seasons out of it. Now, if you go further and then you start fitting, just like in regression you did, a line to it, approximating that some positive and negative distances would cancel out, then that trend line will allow you to forecast into periods 17 and 18 perhaps. And then you add back the seasonality to it to get slightly upper or lower numbers depending on where it's going to be. Most likely this is going to go down at this point. So right after 17 or right around 18, it would be back into this level. So if you pull this up, if you drag this line a little bit up over here, maybe you are looking at a slightly lower number because of seasonality when it's applied back again. So you decompose and then you recompose. That's the philosophy of time series forecasting. So many different techniques. It is usually impossible to know which technique will be best for a particular data set, but the good news is that you can use one or all of 3 measures that we will learn pretty soon. Forecasting accuracy measures. So I don't know if you guys covered the SCORE model in your supply chain course. The SCORE metrics basically stand for Supply Chain Operational Reference Model. For those of you who are not in the supply chain program, this is also a great tool for you guys to refer to, even if you have a finance or marketing major or a strategy major. You will find that this is how operations management really is looking at measuring some of the key performance indicators of how operations are working toward perfect order fulfillment, toward order fulfillment cycle time, toward total supply chain costs, toward upside or downside, demand flexibility. More importantly, demand management accuracy is one of the key measures. So we will learn that, we can measure that with any model that we apply to a time series. And then we need to keep trying and then look for pick best of the measures. And that's your more, reliable forecast, if you will, with minimized forecasting errors, if you will. So several tools are applied. Most of the commercial time series or forecasting models have, several tools that they automatically apply, and they tell you which one has minimum errors. So it's a matter of just using them over time to get more comfortable with them. But in Excel, there are a couple, and we will learn those today. So two important features with time series model forecasting is that it uses historical data for the phenomenon we wish to forecast, and we seek a routine calculation to apply to a large number of cases, and that may be automated without relying on qualitative information about the underlying phenomena. So what happens is that if there is no statistical forecasting in many companies, you will find that the product team or the the owner or the design team, they are trying to forecast without a mathematical way to start, and they use their gut feel. Sometimes that causes a lot of problems because they may be dead wrong that I think red would be the theme next year for our shirts, so let's make 100,000 red shirts. This is, I think, a red would be a theme is something that's based on a very complex process, and while having complete respect for that complexity in people's genius minds, we would like to humbly position that over a long period of time, statistical methodologies will win the game because it is simply applying nothing but the data, the truth that the data entails. And that's the truth that we start with. And then we apply all sorts of, what if analysis and all sorts of intuitions and gut feels, and then we could see if that makes sense. So keeping that in mind, you will always start with a quantitative way of looking at things and then apply qualitative insights to it. But don't be disrespectful of the qualitative side either, because there are people out there with so much experience that they cannot themselves articulate, but they will be able to project using all that years of wisdom and creative thinking. And that's a different strategy and talent. And you should be going to these experts to show this kind of a data analysis and ask them, what do you think? Does this make sense? Why do you think it's going to be different from that? What are some reasons you can think of? And that's a very collaborative process of coming up with forecasting. So short-term forecasts are often used in situations that involve forecasting many different variables at frequent intervals. For example, there are products that you may release on a certain day in a month that will immediately start selling through the day, and people are tracking those numbers by the hour or sometimes real time, and they're looking at how the trend is. Walmart has been doing this for a long time, for example. They have been sharing data on a daily basis to all of their or most of their suppliers, saying, here is the data of how much we sold by your product SKU, by our location, and by price. So do what you want to do with it, but I just want to make sure that our shelves for your products do not ever have less than a 98% or 99% product availability. I understand that you will not be able to get 100% all the time, because then you would have to spend so much money that you may not be profitable anymore. So 99 is okay, or 99, 98 is cool, but you have to maintain that. So ship enough product so that they are over here on our shelves, so that our customers don't walk away because they did not find your product. The reason they're sharing this forecast is because it's a win-win situation for them, as well as their suppliers, as well as the customers, right? So in that case, people are tracking data much more frequently. In other cases, for example, Boeing, if they're determining how many planes they're going to be building out, they really have a longer horizon, right? They have 3, 4, 5-year horizons, 7, 10-year horizons. And in that case, they know that the number of planes they're going to make is not in the millions. It's a few scores. And in that case, what could be potentially affecting their sales? Chevron, on the other hand, has an institute for forecasting future, and for them, future means 25 years out. And why is that? Because they know that if Tesla and other cars come with all these electric models, their entire investment in finding more oil fields and the billions of dollars of investment that go into actually transforming that into an industry, and then really processing that and distributing that and selling that, if it's going to trend down drastically, they might as well look for diversifying their investment dollars somewhere else, or find other ways of channelizing these to different customers and different applications. So it depends on what industry you're in. Aerospace was one example, like I gave you. CPG retail is one example, like I gave you with Walmart. And then with energy, it is a vast future for which your forecasting may have to be a completely different technique. And in many cases, we use what is called a Delphi method, where you're actually asking experts to tell you what do they foresee the economy going to be based on technology trends and disruptions, so that they can make accurate predictions into the future. There is actually an Institute for Business Forecasting, IBF, where there are hundreds of thousands of members, and they all apply forecasting techniques. They talk about evolving and emerging techniques, and it is a profession for many people for their entire careers. So let's get to the math of it a little bit. The math is not all that difficult. It's just symbolic expression that throws off people a little bit, but you guys are all quantitatively pretty smart. You should be able to figure this. So we are starting with the very fundamental moving average model, and we need to talk about that a little bit, because I have often found that people will say moving average or exponential smoothing, not quite understanding the logic of it, on how and why the science of that operates, and what are the good sides of it, and what are the comparable bad sides of it, and how to avoid some loopholes, how to do the right thing. So what this does is it really builds a forecast by averaging the observations in the most recent n periods. And the expression is that A subscript t, which is the moving average, it's based on the first period observed, xt, plus the previous period observed, xt minus, this is the latest, not the first, but I would say the latest period. The second one is the previous period, and it goes until, let's say, t minus n plus 1 divided by n, and we will show you exactly what it is in mathematical sheets. So if you have three numbers, 1, 3, 5, and then you're trying to do two-period forecasting with moving average forecasting, you will actually add up the first two numbers, divide by 2, and set it next to the second number. And then you add the second and the third number, divided by 2, and set it next to the third number. And then you could continue, take those two numbers and shift them one cell down, and the last number you got from the average would be your forecast for the fourth period. And you will see that happening in front of your eyes when we get to the spreadsheet. But the idea is why we are doing this. The philosophy of moving averages is that it is going over a period of time. It may have a long-term trend, and instead of trying to predict every little detail of how the data is nervously, fluctuating over small periods of time, we want to look at a broader brush approach of how it is going to be trending. This broader brush approach is what is achieved by taking data points and then making them, the averages will actually smooth the data a little bit and make it a bit more trendy, and you will see how it's trending out. And then you can make some safe estimations on what interval will that future forecast will lie within without being too much wrong? Because if you just had the whole series of data, then there is too many numbers that could confuse you. It's not really giving you a trend. And that's why moving average kind of, makes it a lot more smoother. So we adopt the following convention for the steps in forecasting. Make the observation in period T, called X subscript T, carry out the necessary calculations, and use the calculations to forecast period T plus 1. So I want you to open this spreadsheet, and you will see this. So the outputs are given here for you to be able to emulate. But let's open this spreadsheet called the classwork data files. And you will see the first one is slide 13 data. Which is over here. So you see here that you have the period T and period 1 to 11. 11 is the period that we wish to forecast in the future. The observed sales, let's say, right, was 73, 106, 76, 89, 106, 113, 96, 66, 104, 76. Again, always eyeball the data, and you're seeing period 1 and period 10 are remarkably close. 2 is where it peaked a little bit, fell down again in 3, slightly rises in 4, takes a huge jump in 5 and 6, and these may be months in a year, we don't know, it could be. And then it again falls down, and then it again goes up in 9th, and then in 10th it falls significantly, which looks a lot like period 1 again. What you want to do is you want to do the following, take the following steps. If you go back to the slide, it says that you need to construct a column which is called AT. AT, I'll show you how it's done. Let me share this screen with you. This 4-week moving average AT, just follow my steps here and you should be able to replicate this for a lot of other problems we are about to do. Just make sure you're typing it out, and this is a 4-week moving average. So we take periods 1, 2, 3, 4, these 4 periods. And right next to the 4th period, we put equal to average of B5, which is 73, to B8, which is 89. So it takes 73 plus 106 plus 76 plus 89 divided by 4. And then you drag it down to period 10. Let me know when you're done. Just put a raise hand or put a chat comment, and I would know that you're done with this step. Awesome, awesome. Now that you're done with that, I want you to write this column, forecast. Just copy what I'm saying, because I'm giving you a step-by-step guidance for this one so that you can try it yourself in the next time. Just copy what I'm saying. I'm giving you a voiceover for what I'm doing so that you can do it next time at much faster speed. Call the next column forecast. And then in the 5th period, because this is a 4-week moving average, in the 5th period, you want to put equal to the 4th period of the previous column. So this is equal to C8, as you can see. It's the same as the previous period's number. And then drag it down, but this time go one more step to step 11, and you get this result. So essentially what you're doing is you're shifting the same data after averaging it by one step further, and you're claiming, and this has a mathematical logic to it, that period 11 forecasted number is 85.50 based on a 4-week moving average. Now, several questions may come up. Who told you the magic number 4? Could it be 3-week moving average? Could it be 6-week moving average? Well, the answer is we could try all those combinations and see which one gives us the minimum error. And we will see that. Then I want you to do the next column, error. And all you do is you take observed actual number, which is 106, minus what was forecasted for that period by the moving average model, which is 86, B9 minus D9, and drag it down. There was no observed number for period 11, so we can't really, do that analysis here. It would show not available. But we are looking at overall performance of the model as it tries to predict based on learning from the averaging out. Then I want you to do the column deviation. And all it means, it's really absolute deviation. And it just takes the absolute value of this column and drags it down. So it's equal to ABS, which stands for absolute value of these numbers. Drag it down. And finally, I want you to do a percent, error percent, let's say, which literally takes this absolute deviation F9 and divides it by the specific number B9 over here and takes it as a percentage of it. And then drag it down. If you just look at these numbers, 19, 17, 0, 53, 8, 25, you see it's making a very good estimation in period 9, but very bad in period 8. And if you take a look at the numbers that you've highlighted toward the bottom of your screen, you see average forecasting error is 20%. So this is error percent, one of the ways of measuring forecasting error. It's a average of the percent errors. So mean absolute percent error, or sometimes called MAPE, M-A-P-E, is 20% in this case. I will pause here until you guys tell me you're ready to move on to the next example. If some of you start typing in the chat window, ready, 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 I will see that you're done. Awesome, 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 great. So let me move back to the PowerPoint. So you've been able to reproduce this. Now, the question was what number of periods to include. There is no definitive answer, but there is a trade-off to consider. Suppose the mean of the underlying process remains stable. If we include very few data points, like 2 periods or 3, then the moving average exhibits more variability than if we include a large number of data points. In that sense, we get more stability from including more points. But if there is an unanticipated change in the mean of the underlying process, it's jumped up. Then if we include very few data points, our moving average will tend to track the change process more closely than if we include a larger number of data points. In that case, we get more responsiveness from including fewer points. It's called chasing the curve. If you expect the data to fluctuate, then use fewer periods in the moving average so that you can chase the curve. If you expect the process to remain like you're selling BIC, B-I-C, those writing pens, ball pens, right? Very stable process. I don't anticipate the sales of something like that, which is a commodity product, or let's say Tide. We don't really expect them to fluctuate significantly. In that case, use 6 period, 7 period, 10 period moving average. You're fine. But if it is something that fluctuates heavily, then you should use fewer points so that you can chase the curve. So what we want to do is we have a fictional example. Open the spreadsheet again, the classwork data file, and go to slide 15 data, and I will share that with you. So if you look at this data, can you take a look at this data and tell me what you see? Just eyeballing the data. What do you see? What's the story that you're seeing there?
Professor, this is Shannon.
Yes, Shannon.
It looks like halfway through the series,
Yep.
the actual observed data point jumps from 100 to 180 and stays and remains there. So it's only 2 values.
Perfect observation. Interesting that, more important than just the fact that there are only 2 values is what you just said, which is whatever those values are, they're significantly changing and staying at that level. Okay? This could have been 101, 107, 103, 104, 107, 106, 107, 102, etc. And then those could be 184.5, 186.7. But we are creating a contrived data set because we want to learn a few insights about what moving averages does. And we'll use the same data set to learn some other techniques and see how each of these techniques perform in these kinds of situations. Okay, so now I want you to go back to the slide, and you see here, first do this, complete these, these headings, 4-week moving average, and then 6-week moving average is another set of data that you will be doing on the side. So type those out just as you see on the screen in the PowerPoint. What you see here is what I just want you to start typing those out. 4-week moving average, and then column C put AT, which is the number that you will be calculating. Column D forecast, column E error, column F deviation, column G percent. Copy and paste those headings and write and paste them over here. 6-week moving average, and we will do the same calculation. And then we will observe just for periods 10 through 15, as it says here in the bottom, for periods 10 through 15, how the forecasting is happening and how the errors are turning out. And then finally, we will take 3 measures of error and compare them. Mean squared error, which is this errors over here, squared, and then added, and then averaged. Mean absolute deviation, which is this absolute deviation over here, an average of those. and then mean absolute percent error, which you just learned in the previous exercise, and average those to generate these numbers and replicate those. So giving you a couple minutes to do this. Typing out is easy, but what you want to do is that you go to column C, this 100, right? It is equal to average of B5 through B8, and then drag it down all the way through 20. Then in forecast, you're shifting this one cell down, so call this equal to C8, drag it down. Error is observed minus forecast, drag it down. Deviation is observed minus forecast, which is this error, or take absolute value of E9 in this case, drag it down. And then percent is the deviation by the observed, and drag it down. Just like in the previous solution that you just did. And once you are done with the 4-week, I want you to repeat the same with the 6-week example, except that here you would start from by taking the sum of these 6 numbers, B5 to B10, and then put it right next to 10, and then repeat the entire process. I want you guys to, once you're done, whoever gets done, raise your hand, and I want you to share your screen and show how you've done it. So for getting the MSE, MAD, and MAPE, follow my logic. If you look at the mouse here where I'm pointing out, mean squared error only for the periods 10 through 15, mind you, which is here 10, which is row 14, through row 15, or it's through row 19 over here. Those are the periods 10 through 15. And there's a specific reason we are asking to do that, because the data is populated there. The rest of it is all zero. We just want to look at the fluctuations there. So what you do is this 2000 will be obtained by the formula equal to average of E14 squared to E17 squared. So specifically, the way you do this is you write sum square, the equation SUMSQ, sum square of E14 through E19, which is E14 colon E19, divided by 6, because there are 6 observations, 1, 2, 3, 4, 5, 6. The sum square divided by 6, sum of squares of this divided by 6. For MAD, MAD, mean absolute deviation, it is just the sum of F14 through F19, that column, divided by 6. For MAPE, it is just the sum of those, again, the same thing, G14 through G19 divided by 6. Because you're taking 6 observations. Sure. Anyone wants to share their screen? Once you're done with both, of course, 4 and 6 week. Just make sure that you have been able to replicate exactly what you're seeing on the screen. Whoever's done, share your screen. Happy to give you control. Just let me know in the chat window or speak up by unmuting yourself. Who's finished? Meet, go ahead, share your screen. I'm stopping sharing. Go ahead. And also unmute yourself so we could hear you. Are you speaking yet, Meet? Because we cannot hear you. Yeah, go ahead. Yeah, now I can hear you.
Okay, so I did the moving square average for week considering 4 and 6 points.
Yes.
So
Yeah.
this is for 4 points and this is for 6 points.
So click on the MSE D27. So it is basically for everyone's demonstration. What Meet has done is exactly what I said, which is equal to sum of square of E14 through E19. Why just these observations? Because I told you to, that only for periods 10 through 15 is where my interest lies, because that's where activity is. Okay, great. Click on the next cell right next to it. So MAD is the sum of the absolute deviation, which is D divided by 6. And then the next one, 8, which is the sum of G14 through 19 divided by 6. Someone has a background. Is that you, Meet? Are you in a noisy area?
No, I think it's just my friend. Sorry about that.
No worries. So now, while Meet's screen is open and Meet, you could mute yourself if noise continues, but I mean, someone else, I want someone else to comment on it. As you observe, the MSE, MAD, and MAPE for the 4-week versus the 6-week moving averages, what do you notice? Who will jump in and tell me what do you notice? Because forecasting error is very critical for us to understand. What do these numbers, these two sets of numbers, MSE, MAD, and MAPE, tell you? How do you synthesize this for the 4-week moving average versus the 6-week moving average?
Hi, Professor. This is Yuki.
Hi, Yuki.
So for when you're using 6-week moving average, the arrow is actually bigger. I think it's because of the trend of this data. It has like a certain jump on the numbers. So when you are using longer period for the moving average, you're catching less of that sudden change. So you have a larger arrow.
Exactly. This is a direct example of the previous slide where I gave you the logic that if it's suddenly fluctuating, then it's actually better to have smaller periods or less number of periods because it will catch the trend. So clearly on all three of them, the MSE, the MAD, and MAPE, the 4-week moving average beats the 6-week moving average forecasting procedure. So you will have a bit more confidence on the 4-week moving average process. Great. So everyone's on aligned so far, or any questions on this problem before we move on? Any part, any step that you guys did not follow or understand? Any confusions? If not, great, and feel free to jump in again whenever you get a chance. But Meet, thank you so much. You could stop sharing, so I will start sharing mine. So we are back to the picture that we had on slide 15. And now we are also, oh, by the way, we just compared those. If you selected with the data that you had before, not this stylized example, if you did the same thing with the data that you had there and completed this process, then I would like you to apply the same logic of 4-week and 6-week again and tell me, first of all, who is doing a better job in forecasting that particular time series and what their individual forecasts are. Clearly, you can see from the screen it's worked out, but I still want you to do it yourself. 85.50 is the forecast based on the 4-week moving average, and the 6-week moving average gives you a forecast of 93.50. So now you're applying this theoretical model of 4-week versus 6-week applied to a stylized example back to the original time series you had, which is more realistic from a real life perspective. And give me the comparison in MAD, MAPE, and MSE. Follow the exact same logic and tell me what it is. Don't do it from scratch because you're going to be wasting time. You might want to copy the formulas over and just, quickly drag them down. So I'll give you 5 minutes for this, and someone needs to share my screen. But what it does not show on the screen is the performance of 4-week versus 6-week in this example, where the data of the time series was the first one that you worked with. And meanwhile, I will take a quick break, and in 5 minutes, I'll come back and ask the question on who has it done. Okay, anyone done? Either speak up or share, or write in the chat window and share your screen. You're going to be working on slide 16 data, of course. I'm sure you figured that out. Jamie, you're done? Or Allison? Shannon? I'm just arbitrarily picking names.
I can share.
Go ahead. I'll stop sharing.
Okay, can you see that?
Yes, go ahead. Walk us through what you got from just the synthesis of all.
Okay, so it looks like it was the same data from slide 13.
Correct.
So nothing really changed. We've seen the 4-week moving average before. 6-week just started the forecast in period 6 for forecasting for period 7. And so overall, it looked like the error, I guess the mean error stayed about the same. I'm not sure if I did this right. I just used period 7 through 10 since I could compare both both averages.
Actually, why don't you do this instead of period 7 through 10? Yeah. You did the right thing because you're comparing those against the numbers that have been observed. 7 through 10. That's right. Correct. So 7 through 10, you got MSE lower for the 6-week moving average.
Yes.
MAPE, same. MAD, slightly higher. So one question is why 7 through 10? Again, as Jamie said, that if you want to compare the performance of the 4-week moving average versus the 6-week moving averages, you are looking at numbers that have values in them. And you see that in the 6-week moving average, the only numbers that have values in them are 7, 8, 9, 10 in the percentage and absolute deviation and error and forecast column. And you don't have data for periods 5 and 6 in this other area. That's why you're choosing to compare just apples to apples. Great. Thank you, Jamie.
Yeah.
So the conclusion, the synthesis here would be that, given the two sets of MSE, MND, MAPE, one has better predictability than the other. If you consider that the MAD number is slightly bigger, but the mean square error is substantially bigger for one case, and therefore you could propose that let's use the other one. After all, MAPE is the same for both, but MSE is significantly better for one case than the other. Thank you. Let me go back to the slides. Now, it's interesting. You have already figured out how to calculate these measures of forecasting accuracy. This is just going the other way around. We typically give you formulas first, and then we tell you to convert that into Excel. But in this case, you have actually done the math, and then you are learning the formula, because this is just assuring you that never let formulas intimidate you, because symbols and formulas sometimes are, a little challenging to decipher, because we don't deal with formulas every day, 8 hours or 10 hours during work time in front of us. But knowing the formulas gives you a repetitive tool set that you can apply, knowing the logic. So the mean squared error between forecast and actual will give you the difference between the forecasted value ft minus the actual value xt, and it says mean squared error. So you take the square of the error, sum it for the periods u through v, and then divide it by the number of observations, which is v minus u plus 1, because it needs to include the first observation. Same for MAD, except that instead of squaring the errors, you're taking the absolute value of the errors for the same period, 7 through 10 in this case, right? So the observations are 10 minus 7, which is 3 plus 1, 4 observations. MAPE, in this case, you're taking the absolute values, absolute deviations, and dividing it with the actual observed number, mean absolute percent error. Percent means a fraction, and then we multiply by 100. But we first take the mean of those, and then it becomes that MAPE formula. Okay? Any questions on understanding the formulas, how they represent the MSE, MAD, and MAPE that you just did yourselves? Okay. So comparison of these measures of accuracy, if you ask me what happens in the industry, 9 times out of 10, I see people presenting MAPE. And sometimes I see that they also use what is called WMAPE, which is weighted mean absolute percent error, the weight being the volume over which this is being done. So for example, a difference between 15 and 17, 15 being observed and 17 being forecasted in a data range that are across the number of variables and observations seems little, but a difference between 1,000 and 980, it seems large, like 20 observations away versus 2 observations away, almost 10 times. But then again, you divide it by the range in which that number is operating, because that 20 may be less than 2% if you look at that entire range. So it's called WMAPE, or weighted MAPE. So MAD and MAPE are similar. One is absolute, the other one is relative. And MAPE is usually reserved for comparisons in which the magnitudes of 2 cases are different. That's what I gave you an example of. 15 versus 17 on the one hand versus 1,000 minus 980, which is another magnitude. In this case, MAPE actually gives you a good understanding of what happens. Now, in Excel, actually, there is a moving average solution. If you go to data analysis and then go to moving average, you will find that it will do the moving averages for you. Excel assumes that the data appear in a single column, and it also allows you to select a title. And the options are using a graphical display for the actual and forecast data, and a calculation of the standard error after each forecast. So if I go to the Excel spreadsheet, and if you look at these to be the observations that you want to do this for, you could go to data, you could go to data analysis, you could select moving averages. You could hit OK. And in this window, the input range, you could select these numbers. I'm not including the labels in the first row. I could, if it really makes sense. It's just observed. Interval, I want to use 4 periods of moving averages. And the output range, I'm saying put it from the 4th observation onward. Actually, I'm not forecasting yet. And chart output with standard errors. And it gives this observation along with 85.5 to be the last number. Not applicable for these because you don't have numbers where you can compare them with. It's just taking those numbers where I could have started, by the way, I could have just done this. Let me just do this again. In fact, don't save it, pull it back up again, and then share. I have to open this classwork data files. And I'll go to slide 16 data. I'll take those and I will take a moving average. Am I sharing yet? Let me make sure I'm sharing. Share classwork. New share is what I need to do. Share classwork data files, share. I will go here. I will go to data, data analysis, moving average, okay. Input range is B3 to B12, interval 4. Output range, let's say here, I change this to do it here in this column, just side by side, chart output standard errors. And you see now how it is showing me the numbers that are calculated here, 85.5 being the one. Okay. And then it is also doing square root of sum of all these values and then basically showing you these squared errors. And in this case, you could make the chart slightly bigger. You see that the actual was like this, fluctuating a lot, and I'm trying to determine a trend. And in using 4 moving average periods, it has given me a dampened version of the forecasting. And it shows the trend is going slightly up and then down. And that's how you figure out how it's going to perform next. Okay. So I will go to this slide back again. Now the next model is the exponential smoothing model. And the theory of this is that this puts more weight into recent observations more than older ones. And that is something that you will see in the industry a lot because the industry fluctuates a lot. It moves a lot. It has changed. The same assumptions do not hold more. So taking data from a long time ago versus the most recent data will actually give us more errors. So what we try to do is we put more weight into the most recent observations. Let me explain the theory first. So it says a smoothed value of the observations is alpha times the observed value for period t. Alpha is a number between 0 and 1. It's a smoothing constant. How to select it, we will learn. Plus 1 minus alpha times the period st minus 1, the smoothed value of t minus 1, the previous period. This is equation 1. And then the forecasting procedure sets the forecasted period of future ft plus 1 to be this, and then it keeps on forecasting for the future periods. How this works is that st minus 1 would be alpha xt minus 1 plus 1 minus alpha times st minus 2, going by the same logic. Substituting this equation into the previous one, so st minus 1, instead of this, you are going to use the new value st minus 1, which is a alpha times xt minus 1 plus 1 minus alpha times st minus 2. So then what happens is you get, by collecting the factors, alpha times xt plus alpha times 1 minus alpha times xt minus 1 plus 1 minus alpha times 1 minus alpha, which is 1 minus alpha squared, st minus 2. And if you continue to substitute this way, you can eventually express the equation that you saw in the first equation to be alpha times xt plus alpha times 1 minus alpha times xt minus 1 plus alpha times 1 minus alpha squared xt minus 2 plus alpha times 1 minus alpha cubed xt minus 3, and so on and so forth. And what happens with that? Since alpha is a number less than 1, this coefficient before xt minus 2 and xt minus 3, the previous observations, they decline. So you're putting less and less weight into the past. The next one would be alpha times 1 minus alpha to the 4, xt minus 4, which is even a smaller weight to that. So we can see that the forecast is a weighting of all the observations, applying the largest weight to the most recent observation, the second to the second most, and so on. It is not as drastic as the moving average formula because it does not completely discard old data after n periods. It just puts less weight in it. In moving average, you are completely ignoring 1, 2, 3 if we were doing 4-period moving average, or 1, 2, 3, 4, 5 if you're doing a 6-period moving average. Here, you're going to be able to look at all the data and be able to generate a forecast for all of it. You just need to assume an initial condition, which is typically taken to be the number observed for that first period to be the starter number, and then you will be able to generate forecasts. One interesting observation is that if you compare the weights placed on k-year-old data, for alpha equals 0.2, you have, for 1, 2, 3, 4, 5, the weights following that logic is alpha times 1 minus alpha, then alpha times 1 minus alpha squared, plus alpha times 1 minus alpha cubed, etc. Those numbers are calculated here. And you see the result for alpha equals 0.6 is that it goes like this, a much more drastic drop of weights for the future periods, rather than alpha equals 0.2, which puts less weight in the previous periods, but not that much. It completely depends upon your understanding of your industry, whether you will put a lot less weight in the previous periods versus a little less weight in the previous period. If you want to put just a little less weight in the previous period, take an alpha that's 0.2 or small, 0.1, 0.3. If you want to put a lot less weight in the previous periods because nothing closely resembles, from 3, 4 periods out, nothing closely resembles what you're seeing now in our industry, then take a high value of alpha. Okay, I'll pause there because this is so critical. One of the largest entertainment companies was implementing SAP with $100 million, and they had implemented supply chain solution, which includes demand management solution. And I met one of the developers in the airport in LAX. And I asked him, how is it going? They said, it's frustrating. And I said, why? And the developer tells me, because I go back to the executives and their directors and their senior directors and their analysts, and I ask them, hey, I am here to implement SAP for you. I need to know what value of alpha you want me to use for forecasting your DVD sales. And nobody could tell me an answer because they had no clue on what alpha meant. And without that, I assumed an alpha because I had no other option. And obviously they're getting very, bad forecasts, and they're blaming it on us, telling us we don't know what we're developing. And that's why I'm frustrated, because the managers don't know that putting a weight into a recent period depends upon how your company and your industry operates, and therefore this slight knowledge learned from an MBA program or a master's program like this could go into a $20 million of saved opportunities, because the forecast errors obviously were generating huge amounts of inventory, and they were all blaming it on the developer. So as informed citizens, informed executives, informed middle managers, the more you know about these basic concepts, the better you'll be able to apply them in real life. So now you know that if in my industry, in the DVD industry, for example, the alpha value for the previous period is a lot less significant, or 6 weeks out or 10 weeks out or 14 weeks out is a lot less significant, because the whole life of a DVD sale is literally 8 weeks. So therefore, you are better off taking alpha is a small value, like a 0.2 or a 0.1, right? So just wanted to share that real life insight with you, why we are learning these things. Okay, so now open the worksheet for exponential smoothing calculations, and I'm showing you the formulas here, and we will repeat that. So let me share my screen. And I want you to repeat that. I will go to this one here, exponential smoothing example. So the data that you have is for periods 1 through 20. And the observed values, you have 73, 106, 76, etc., all the way through 73. And please create the headings first. ST, forecast, error, deviation, percent. Don't type it out, copy it from the previous slide or previous worksheet. And then side by side for comparison, you will also do a 4-week moving average on the same set of data with AT this time, and then forecast, difference, deviation, and percent. Once you're done until just getting the headings out, let me know, because then I'm going to walk you through how you're going to be putting those formulas. Please write ready on your chat window when you're done with this part, so that I could move on with the rest. Okay, great. Great, great, great. All right, so fantastic. Now, I want you to go to cell C6. And all you're doing is, this is called the initialization of the forecast or the series using exponential model. So all you're doing is you're setting it to be the same as the observed value 73. So just type 73 in there. Or you could do equal to B6. Then you go to the next observation, which is C7. And this follows the formula ST equals alpha times XT, which you just learned, plus 1 minus alpha times ST minus 1, which says alpha is the value C3, which is 0.2. And by the way, that's your parameter, just like you did in linear programming model. Just write alpha 0.2. So you could refer to that number. Do not forget to put the $sign both in front of C and 3, because you want exactly that number to be used in the calculation, times B7, which is ST, which is basically this number, XT, sorry, not S, but XT, which is 106, plus 1 minus C3, which is 1 minus alpha, times ST minus 1, which is the previous period 73, which is C6. This is how you initialize it. And all the work you have done in this cell will pay off for millions of rows now. But drag it down all the way to the last observation and see if it replicates exactly what you see on my screen. Let me make it slightly bigger for all of you guys. Again, give me a done so that I could go to the next step. Awesome. Then I want you to go to column D, and you are setting it as C6, just shifting it one down. And this to be C7, and this to be C8, etc. Drag it down. And then I want you to look at periods 5 through 20, as it says here. And therefore, the errors will be calculated from this period. So it's forecast, observation minus forecast, so D10. So this is forecast minus, it's either way, it's fine because we'll be squaring or absolute valuing them anyway. But still, take forecast minus, observe value and drag it down. And repeat the same with this as absolute value of E10, drag it down. And then go to G10, which is this deviation number F10 divided by the observed value, and it's a percent form, drag it down. And repeat the MSE, MAD, MAPE process just like you did before. So the only thing that you did here is that you picked an alpha 0.2, and then you could start, creating a graph, if you fancy that, with many values of alpha equals 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, all the way to 0.9, and see how the MSE, MAD, MAPE changes, and you can determine which alpha is serving you the best. That's the cool thing about forecasting. The errors tell you a lot about what to do. Then you go into the 4-week moving average, and you know how to do it exactly, which is taking the first 4 observations and then equal to this divided by 4, drag it down, forecast, which is shifting it down by 1 lane, drag it down, differences, deviations, percentages, MSE, MAD, MAPE. And tell me when you were able to replicate the exact numbers. One good thing to do, one good practice to do is to make sure that the decimal places stay at 2. Don't go for 4 decimal places and all that, because it's cumbersome. It does not inform us anymore. So make it 2 decimal places. And again, start typing done when you are done with this step. So once you're done with the MSE, MAD, and MAPE between the two techniques, if it's mathematically not so obvious, you have to make a judgment call. MAPE has a huge amount of respect in the industry only because in the long run, it allows us to take into consideration all sorts of fluctuations. MSE, because you're not taking the square root of that, tends to show more fluctuations only because the numbers are squared. So if you look at these two sets of numbers, MAPE for the second one, 4-week moving average, is actually a better performer. So is MAD. But MSE for the exponential smoothing technique is slightly better than MSE in the third, in the second case. So 2 out of 3 candidates lets us break a tie, and then I may have other reasons on why MAPE is a better indicator, or maybe in our industry this works better, or maybe in this particular product line this is a better indicator. But if I were to make a judgment call here, I would go for the 4-week moving average in this particular case. And again, remember, for all different cases, there are all different techniques. The good thing to do is to follow the 3 types of errors and then pick the one that has 2 better than the other one. In this case, these 2 are better than those 2. Okay, so let me go back to the PowerPoint for, and by the way, comparison, if you just plot those, you will see that the, observed, smoothed, and averaged. Observed obviously is jumping a lot more. Smoothed is going to be a lot less because you have smoothed it. And the average, moving average is here. It shows a little bit more fluctuation. In Excel, you could do exponential smoothing. How would you do that? You will select exponential smoothing from data, and you saw the screen there. It asks for a damping factor, which is the complement of the smoothing factor, or 1 minus alpha. options exist for chart output and calculation of standard error. So you could literally do that and generate a same set of, a similar set of numbers there. I will let you do that, but real quick, if I share my solutions forecasting, I could go to this, for example, or I could actually go to my classroom exercise classwork data file and go to this data, and I could say, hey, take me to data solver, sorry, not solver. I just inadvertently clicked on that. Data analysis, close. Close. Oh, come on. It will keep doing this until I ask it completely to close and forget about I even asked. Sometimes solver, when it has advanced solver in it, it keeps confusing between what which instance is running, and it will keep giving you this issue. And I will go to exponential smoothing, okay, and it says input range. I'm taking, let's say, these. Damping factor, put 0.2. Output options, output range, I could put output range. I could put here, sorry, here. Chart output with standard errors. So again, the graph comes out small, make it super big to actually see what's going on. And you see it has done the exponential smoothing with output generated here. And the actual, what exponential smoothing does is that more than dampening, which moving average does, it actually tries to chase the curve. It is trying to chase the curve and then predict outside that range, what that number would be. So in a second, you could do the exponential smoothing, observe, the whole calculation done by Excel for you, where you don't have to painstakingly type the formulas, but knowing what the logic is certainly gives you a lot more insights, which is why we went through that process. Going back to the slides, we're almost done. Remember that there are many, many other techniques of forecasting that allows you to de-seasonalize the data, de-cyclicize the data. One such method is called Holt's method. And it's a more flexible procedure which uses two smoothing constants, alpha and beta, as shown in the following formulas. The first formula seems familiar, but it takes ST equals alpha times XT plus 1 minus alpha times ST minus 1 previous period plus a factor T, which is a trend factor. And that's given by T, subscript T, equals beta times the smoothed value differences of the previous period and this period, plus 1 minus beta times the actual, value from the previous, the T value from the previous period. And the forecasted value is given to be the sum of, this is the additive model, if you remember, ST plus TT. So now you will be able to look at the spreadsheet for the final one, which gives you the data for slide 29. And you will follow the formulas given here exactly the way it says. I will show you that. So let me share that screen. This is the one that I'm sharing with you that you will be reproducing, and we are done. So create, unless it's already there, this row which has alpha equals 0.2, beta equals 0.5 as parameters. These are the observations you should have. I think you have 30. There's a split screen, by the way, for comparison, but don't worry about that right now. And then ST, which initializes at the first number 100. And then the second one is the formula that you just saw, ST equals alpha times XT plus 1 minus alpha times ST minus 1 plus TT minus 1, which is exactly what we're doing here. C3, don't forget the dollar signs, which is alpha, times XT, which is B7 for this period, plus 1 minus C3, which is 1 minus alpha, times ST minus 1, previous ST minus 1, plus previous TT minus 1. So this is C6 plus D6. You initialize that to 0. And in this case, here, you initialize this to 0. The second one is beta times ST minus 1 plus 1 minus beta times T minus 1. So exactly that. E3, which is beta, times C7 minus C6, ST minus ST minus 1. And then plus 1 minus beta, which is 1 minus E3, times D6, which is TT, in this case, TT minus 1. Forecast, in this case, remember, you can't just drag and shift it and pull it one more down, but you're adding ST for that period, plus T subscript T for that period, 100 plus 0, 100, and drag it down. And then error, which is forecast, minus the actual, and drag it down. What this is doing, again, to summarize, to understand what you know that you're doing right now, is that you're looking at trend and seasonality, and Holt, and also called Holt-Winters model, is an elegant tool that combines both elements and then allows you to forecast with greater degree of accuracy, because now you have an idea of those two factors, how it affects your time series. This will have a better forecasting ability. If you drag it down one more row, you will be much more confident about how this is working. It's going to give you a forecast of 327.7, which combines the seasonality and trend for you. So let me know when you're done with that, and we will go to summarizing. And again, you see here how you could create a sensitivity table for at t equals 25 for different values of alpha and beta. You could do a lot of combinations, and you will see how sensitive they are and what numbers would, what the deviations would be. Okay, so let me make sure I'm sharing the right. Oh, okay. So this is for sheet. Let me open the classwork data file. Interesting. I don't have that data. Why don't you just let me copy that data and solutions. copy, classwork data file, paste. Actually, I will paste here. And then save this. And then I will go to session, file, updated with holds example. Can you download the spreadsheet, which is the updated classwork spreadsheet, which is called updated with holds example from Blackboard? And Yuki, absolutely, just like I do every class, after the class, we will upload the solutions for the work we have done in class, and then make sure that the same thing is done for homework. Bonnie, you're asking, how can we determine alpha and beta for the business or the company? So, just like you saw in the spreadsheet, let me go back to the spreadsheet if I'm not sharing it yet, just making sure. Solutions, yeah, that's what I'm sharing, I guess. So if you see here, Bonnie, that in the spreadsheet, there is an area of sensitivity analysis that you could generate for alpha and beta values. And for any period, it will generate how the error fluctuates. So if you take an alpha equals 0.2 and beta equals 0.8, there is a huge fluctuation of error. But if you take alpha equals 0.6 and beta equals 0.4, there is very little. So you could work with this or this, 0.6 and 0.6, 0.6 and 0.8, and there are many other options. But obviously you want to avoid the larger error percentages. So now you should have the data that I'm showing here. And I'm also showing you the formula. I'm displaying it on my screen so that you could copy it and reproduce it. Sometimes just making sure you are copying it with an understanding of what is it that you're doing. That's why I put the comments out as labels. So you could follow the labels and see what the math behind that is, and then go back and make sure that your value of C3, so you have to create that row, right? Alpha and beta. Don't worry about the right-hand side sensitivity of error at this time. Just make sure that you take the data and have alpha and beta values. And I have highlighted C7, and I'm double-clicking on it. So on the top, you see the formula that you need to copy and paste. And by the way, make sure that your rows are actually those, because otherwise you will have no values there. So in my case, it started at period, row 6. So, and the values of alpha and beta are in row 3. That's why you see that formula. Make sure once you put your rows there, you refer to the right row. Obviously, you guys all know this, but sometimes we forget because we're in the weeds and we forget that, what that process should be. And once you're done with that, let me know. I am now showing you the value of T, which is based on beta, as I walk you through it, and 1 minus beta, C7 minus C6 in this case. The ST minus ST minus 1 plus 1 minus beta times the previous T subscript T minus 1, which is the previous number, which is highlighted in green. and drag it down. And forecast and error are things that you know how to do, so you should be able to drag it down and do it. And then finally, you should do the forecast. In this case, ft plus 1 equals just a sum of those previous two numbers, st plus tt, and drag it down. If I see like a couple dones, then I will be confident to move on to the next slide. Again, guys, remember that the text is a very good narrative of what we are doing. So in class, you will see distilled bullets in a PowerPoint, working sessions. We are doing the problems together, but still there are areas that will remain as a little confusing because your brain cannot absorb that much information in that little time. So go back to the text and read through the worked out examples that we have picked from the text, and you will see the explanations that you may have missed in my voiceover. Take it as a second voiceover, and most of the time you should find the answers. This, unlike other courses where a text is used more as a reference, this is a working textbook. We take the examples from here, we take the homework problems many times from here, and as a result, what happens is that there is a direct correlation between what you're learning in class and what you can go back to the text and read as explanations. Any questions on this so far? Okay. Anyone done? Awesome. Nikhil's done. And of course, I will upload this spreadsheet for your benefit, and you should be able to save that along with the comments. And now let me go back to the PowerPoint. So exponential smoothing with trend and cyclical factors. You know, for a cyclical effect, in fact, there are two types of models, again, additive and multiplicative model. And I have actually given you Holt's way to be a great way of doing that, but the text has some additional formulas for those of you who must look at a cyclical or a seasonal factor. But content-wise, let's make sure that you have hit these ones today. And then we will go into talking about your key takeaways. One is moving averages and exponential smoothing are widely used for routine short-term forecasting. By making projections from past data, these methods assume that the future will resemble the past. When it does not, to Shannon's earlier point, if the past does not really tell us more about that particular product, then you could use something like a Bass's model, and I will just add that here. for completely new products try Bass's model. You will find a lot of references of that in Wiki as well as online, and there are like Bass model tools that you should be able to use, and it will ask for certain parameters based on your industry understanding, and it will look at those as potential candidates for solutions to compare with. However, the exponential smoothing procedure is sophisticated enough to permit representations of a linear trend and a cyclical factor in its calculations, and it's adaptive. It chases the curve. Implementing exponential smoothing requires that the initial values be specified, which is how we started, as taking it to be the number in the previous observation, and a smoothing factor be chosen. If you don't know what your alpha is or should be, then you are in trouble. It should be chosen to trade off stability and responsiveness in an appropriate manner. And although Excel contains a data analysis tool for calculating moving average and exponential smoothing, the tool does not accommodate the most powerful version of exponential smoothing, which includes trend and cyclical components. That's why you saw how we did that holds part in it. And there are a lot more forecasting tools available today out there in the market. Oracle has one, DP, it's called demand planning. SAP has one, it's also called SAP DP, which is demand planning. JDA has one, which is a combination of what the I2 technologies used to have as demand planning, and then Manugistics, which very descriptively is manufacturing and logistics. It's a software used to have. Their forecasting tool was really cool. For CPG companies in particular. So many of these companies have their own forecasting tools that you should be able to get as a package solution for your company. And then they also have SaaS tools today, meaning software as a service. SAS, the statistical tool, R, the statistical tool, Python, they all have forecasting tools. So if you really want to look at this as a career strength, then I advise you to make sure that you learn those software tools. This is an Excel exposure to the basic business logic of what it is that you're doing. You will get a lot more efficiencies and features and functions in those other software tools. So who wants to share key takeaways today? Who'd start?
Hi, Professor. This is Allison.
Yeah, go ahead.
I think I didn't realize before that using the MSE, MAD, and MAPE, you can compare two different forecasts and to understand which one you might want to go with over the other. I don't work on that side of the business at my company, but I definitely want to go and ask our inventory management team about this when I go into work.
You're gonna get a stare.
I know.
What all this?
To bug them about how they're tracking the accuracy of the forecast. So that was interesting to know that you can use that to compare to. And then I think the point that you were talking about, a company had implemented a big system and they're just wanting it to kind of run the business. We just implemented a new ERP over the last few months, and we've had some similar commentary from folks on the team, not quite understanding that we have to configure it to our business needs and our business case. So
yeah,
interesting to hear it happens at much larger companies too.
Yeah. What ERP are you using?
We're using NetSuite.
Okay, great. And then you will face these questions.
Yeah.
What's your alpha? I mean, I call it the "what's your alpha" joke, and very few people know the answer to it, even if they're running their business, because they don't know these tools. And it's changing. It's changing a lot because you're getting more and more MBAs in these levels and MS folks in these levels, and they have had the exposure to these. And some schools are more quant than others. I prefer the quant way because it gives you a huge advantage over people who don't have that quant, and they're trying to struggle, just to gain wisdom from experience. But wisdom and experience will come even faster if you start with a quantitative starting point, like knowing your alpha, for example. So great comment. Thank you. Anybody else, please jump in. Who'd like to go next? Any key takeaways? Who will go next? Need at least a couple.
Hi, Professor. This is Yuki.
Hey, go ahead, Yuki.
So what I learned that as we learned like 3 different approaches to do the time series forecasting for different problems, we need to decide which one to use based on how the past trend of the data is. Otherwise, it would be generate great error and the forecasting won't be very accurate.
Yeah, and to do that, always look at sensitivity analysis of taking the right alpha, right beta, smoothing factors, and then comparing with the forecasting errors so that you can pick a model, right? So yeah, the past trend is obviously going to be very important, particularly when you saw that example of 100 to 180 jump. One might say, hey, this is a big jump. Should we even put any value in the hundreds anymore? Because it seems like a matter of the past. And the past trend, to your point, Yuki, in this case is misleading because we are now in the 180 world, right? So yeah, good observation. Anybody else? If not, I'll post the homework problems soon and start working on them while they're fresh. Keep your book in front of you. Pages 160 through, actually 167 onwards through 177 has most of what we have covered. In fact, it goes into a few more models at the end. And solve these problems and be ready with it. Next week, we will get into a bit of data science and data mining. Well, this is all data science, but data mining is an interesting thing that you will get a lot more insights from. Until then, have a great weekend and a great week going forward. And feel free to reach out to me, email or otherwise, and set up time if you want to talk, or just email me with any questions that you may have. Okay? Thank you, everyone.